So today I'm going to try to flesh out a concept that I mentioned in the previous video, but I did not really get into too much. Um, and it's called state machines. From the Polkadot documentation, parachains are what they call deterministic state machines. So let's discuss what that means. Deterministic means that each parachain has a state, and the state transitions are blocked. So every time you add a block, it is a state transition. Or yeah. They're infinite because uh, they, they're, the states, there's no limit to the number of states. Every time you add a block, you have a new state. But let me go back and discuss, um, first of all, to understand the state machine, let's talk about some basic definitions. First one is a Turing machine. And I have a funny story about that at the end. It is defined as an abstract computational machine that can simulate any algorithm. And from Wikipedia, basically the concept is it manipulates symbols on a strip of tape according to a table of rules. So you have data, you have rules, and you process that data according to the rules. And there's also another, and there's also a something called that. So a Turing machine is a mathematical model of computation that defines the abstract machine. As I mentioned, it manipulates symbols on a strip of tape. It's basically taking data, manipulating them, going to another state. So, given any computer algorithm, a Turing machine is capable of simulating that algorithm. There's also a concept of Turing Complete. Well, what does that mean? That it's an abstract machine, for example, a programming language that can emulate a Turing machine. In other words, it can emulate any computer algorithm. As we mentioned, an infinite state machine as a blockchain, there's a start state, there are no end states. Every time a block is added, you have a new state. So the Polkadot blockchain is a infinite state machine that is Turing complete. So from their definition, a state is like a system's configuration. Basically, it can be on and off. Each of the state transitions contains a set of switches, and the logic, in essence, determines which switches are to be toggled. That's their definition. Basically, you add a block, you have a new state. You transition from the state of the blockchain to a new state of the blockchain. And it's infinite and it's Turing complete. So let me talk, to understand, I think one example that would make it pretty simple is a deterministic state machine that we all are familiar with called a traffic light, right? A traffic light has three states. And this is a good example I mentioned in one of the things I was reading. It has a red state, a green state, and then a yellow state, right? It's red state, you stop, green state, you go, yellow state, you see how close you are to the light and determine whether it's better to go before it turns red or to prepare to stop. So basically three states. As I said, with a blockchain and and obviously the Polkadot blockchain, it's infinite. You know, you're always going to have new, block comes in, state change. So hopefully, to give you an idea of what this thing, a more visual idea, as you may or may not know, Polkadot, one of the people heavily involved in, was also heavily involved in Ethereum. There's a lot of similarities. So what I'm going to do is I'm going to show you this here. So this is Etherscan. And this is the blocks. So you can see the state, the blocks, all the blocks lined up, the amount of gas. If I refresh this, as you can see, it has changed. So this is how the Ethereum blockchain is in essence an infinite state, because state has changed, blocks have been added. So hopefully this helps you understand the concept of the state transition. So in creating the blocks, adding the blocks, and as they define it here, again, the state transition is a block. So you add, as I've been saying, add a block, have a new state of the blockchain, or in this case, you have the parachains. And with the relay chain, which hooks up all the parachains, you of course have then the state of the Polkadot network. Just a quick funny story to end this discussion, since we were talking about Turing machines. Years ago when I was in grad school and I was taking the class on algorithms and so forth, and we were studying Turing machines, I came home for the holidays, and I went with some friends to see Breaking the Code. And I didn't know, I knew it had something to do, I think, with, the World War II, breaking the Enigma code. What I didn't know until I walked into the theater and got the playbill, this was Broadway when they actually allowed them to, put people in the theater. I opened it up, and I'm looking, main character, Alan Turing, and I'm like, oh my goodness. I was just studying about this fellow's work, and finite automaton, all the theoretical computer science that this gentleman did. Dr. Turing was a brilliant computer scientist. So anyway, I thought it was kind of funny that, that looking in the playbill, I'm like, oh, wait a minute, this is about the guy I've been studying. So anyway, I hope this has been helpful, because this is a concept that takes a little bit to get your brain around. So anyway, I hope this has been helpful. If it has, give me a like, please. And if you're interested in seeing more, please subscribe to the channel, and you will then get notified when I put up new videos. Thank you very much, and take care.